Hello everyone and welcome to part 4 of our Lifehack series about ZR-Effekts. My name is Patrick Shoemaker from NUMECA Engineer Bureau and official channel partner from Cadence Design Systems. And in the previous Lifehacks, I already showed you how you can create ZR-Effekts from a geometrical point of view, how you can create your grid, how you can create matching connections. However, based on some feedback from our customers, we noticed that we were missing some important examples. For instance, we showed you how you can define your ZR-Effekt by importing a geom turbo, our format for defining a turbo machine, and create your or complete your ZR-Effekt there when the curves are already predefined in the file. However, that is not always the case. So today we will cover different aspects from the geometry generation specifically linked to the generation of curves. And we have quite some content to cover, so I prepared a short slide for you in order to give you an overview about what we are going to talk about today. So as I mentioned, we will be talking about the generation of curves, and we will do that with different approaches. So we will talk about manually creating curves by importing CSV files in Fidelity. We will show you how you can interactively create those curves in Fidelity based on some geometry or from scratch. And I will also show you very briefly how you can do this by using the Python API. The next step will be how we map these curves from a Cartesian view to the Meridional view. This is also an important aspect. And as a part of the previous 2 points, we will also be addressing the 3D selection mode, because this is actually an important feature in Fidelity that you have to understand in order to switch between the different views and the different parts of the geometry. We will get to that in a minute. All right, so let's get started. Let me just pull up the user interface. Here I start with a very simple configuration showing a radial compressor containing only the impeller, and our objective is going to be to add a ZR-Effekt and define the domain. And the first way, as I mentioned previously, that I'm going to show is to use CSV files. So in the cut tree on the right-hand side, if you use the turbo template, I can import a geometry. And instead of using this option here, import geometry, I can also say import curves from CSV files. In my example, I will have 2 curves defining the ZR-Effekt, and I can choose how the curve or which type of curve is essentially created, because those CSV files only contain a cloud of points. They do not contain the information which type of curve is actually created. This is something that is up to the user. So for instance, I could decide to create a B-spline, a C-spline, or, and that is going to be my choice here, a simple polyline. So now I have those 2 curves here, and what I would like to do is I would like to map them to the Meridional view right here. However, if I do it just like this is a button that I already explained in some previous life hacks, append to the Meridional view. This is not going to work. Why? Because I have not chosen the correct selection mode up here. I will circle back to that later. Right now I will just go to Surface and Curves, redo what I just did, and now my curves are here in the Meridional view. So this was option 1. Option 2 is going to be, if I circle back to my presentation, interactively in Fidelity. So let me just delete those two curves here. And I think I'm also going to delete my turbo configuration so we can start from scratch. So here I have a cut model or a CAD model from my radial compressor stage, which I would like to use to create the curves that I need to define my ZR-Effekt. And I will not do this for both curves. I will do it just for one curve in order to show the general workflow. So here, essentially, I would also have multiple options. I could just use directly these curves right here and map them to my view. As you can see now, they are mapped. I think I forgot one. Yes, this one right here. Or let's say let's imagine for 1 second these curves would not be present. I could also use, for instance, this tool right here where it says split along an isocurve. And then I can just jump in there and create my curve and take those curves and map them to the meridional view. That's pretty much up to you, but that would be essentially part or option 2 to define the curves right here. Option 3 is essentially the same what we did at the beginning, but we use a small Python script to do that. So you can just take a screenshot from this or pause the video. It's actually, there's actually not much to it. What I do here is I assemble my directories. I have 2 files which contain information about my curves, and then I just import them. I'm using the pandas library here. This is something that is also completely up to you. And then here I create either a C-spline or a polyline in Fidelity using the points contained in those 2 files. I already showed this a couple of times, I think, so I will just go to run Python script. I should have my code somewhere here, code. And now I imported my curve right here, C-spline and polyline. It just renamed it because I already had them present previously. So that was part 3 or option 3 to create the curves. So we covered these points right here. I also briefly addressed those 2, but especially the 3D selection mode is something that I would like to emphasize again, because it's actually really important that you understand this. And I will demonstrate this on the cut assembly to begin with. Let's start maybe with the 3D selection mode. This selection mode essentially refers always to anything that you select here on the cut tree. So for instance, if I click here, I get the hub. If I click here, I get my assembly for the blade. So this is a very generic selection mode. If you want to go more into the specifics, you have this option right here where it says assembly graphical selection mode. So if I click now, it will create or it will select the assembly, no matter if it's just a curve or a surface. It will always select the complete assembly. Whereas when I go here to boundary group, it will always select the complete boundary right here. So now I selected the hub. If I go back here and I select this surface, it will select all surfaces here that belong to the boundary backface shroud. If you specifically want to select curves and surfaces, then you need to use surfaces group graphical selection mode. And now you are able to select specific surfaces or to select specific curves. And this is the mode you need in order to, for instance, take these curves right here and map them to the meridional view. So let me just do this for this curves right here. Oops, that was a surface. I didn't want to do that. And now I can use this button right here, append curve in meridional configuration. Let me just do this really quickly also for the hub curve. And now I have almost everything I need in order to define this ZR-Effekt right here. I will have to add one more curve because this domain here has to be closed in order to be defined as a ZR-Effekt. I think I mentioned that in one of our previous life hacks. And now I can say create ZR-Effekt, boundary definition, and now I can use this curve. This 3D selection mode is also relevant in this meridional view or in the family view in general. So for instance, right now, everything you see here will be one boundary. So you can verify this by going to domain. So here a new domain is created for the ZR-Effekt. And if I open up this tree, you will see you have one boundary right here. However, if, for instance, you would like to place an outlet boundary condition here, or if you want to connect this domain to a domain downstream of the impeller, then you will have to split this boundary into different sub-boundaries. And this is also something you can only do if you have the correct selection mode, which is the family selection mode in this case. Now, if I select this, I can click on this curve, say show control points, and now, and only now, I can say, for instance, boundary division, select outlet or rotastator or whatever for this boundary. And now if I go to domain, you will see you have 3 domains where you had previously only one boundary. I'm sorry, I think I just misspoke. So we splitted one boundary into 3 boundaries, which was only possible in this case if you change the 3D selection mode. So be sure to just play around with it and make all the mistakes you can make. I basically did the same. There is definitely a logic behind it. You just have to learn it. All right, I think that was pretty much all I wanted to cover for today. Be sure to give us feedback again, play around with it, and yeah, have a good time.